Hello, everyone. Welcome to BrisJS. You hopefully you've jumped on our live stream, and we've got everyone joining in. We've got some of the concurrent viewer counts going up now. So thank you very much for joining us tonight. We'll just give that a minute to let everyone get that alert and start joining the stream, and make sure that everyone has the opportunity to kind of contribute to our Q&A tonight for tonight's speakers as well. So we'll have a couple of folks today, and some longish headline sessions today, so that you can ask a lot of questions then at the end of each piece, and we'll get around to providing some of the details there as well. But of course, as usual, we'll use Slido, and I'll bring the link for that up so you can get set up. And then I'll do a quick preamble, and we'll get straight into our talks tonight. Just do a quick announce as well. Okay, good stuff. Thanks everyone for joining in. I can see the viewer counts going up. We're getting into it. I think it's safe for me to start some of the intros. Oh, good. All right. So it looks like we're on a significant delay today, and I'm not sure if that's a new YouTube issue or if that's something where Zoom and YouTube aren't getting along. But yes, there is a good maybe 20-second delay as far as I can see here, which is unusual. But we're normally around about 5 to 10-second delay intentionally, but that's hopefully something we can put up with. Yes. Hi, everyone. Got people getting in there, and hi, Genevieve. Everyone coming in. All good. All righty. Let's crack into it, shall we? I will make sure that everything's shared. So I will jump straight into the slides. You've obviously had a chance to connect to Slido. So what is Slido? It's our way that we're grabbing your feedback, your Q&A, and making sure that we can ask our presenters some of these questions at the end of their session. So if you've not used it before, it should be hopefully really easy. You've got an easy number to punch in there as well, 222. Otherwise, there's a link in the YouTube chat that you can follow, and that'll take you to that as well. If for some reason that's not working out for you, and maybe you're on a mobile, feel free to use the YouTube chat as well. I'll be able to ferry some of those questions into Slido for you, so that'll be fine. I'll do that all in the background. All good. All right, folks. Let's start off with our acknowledgement of country. So it's still really important no matter where you are, and this is a live stream, so we're going to acknowledge the traditional owners of the site which we broadcast from today, which is the Yugara and Bundjalung people. So we'd love to pay our respects to the traditional owners of this location, and pay respect to elders past and present. And just a quick reminder that we have our YouTube page. Hopefully you're all very aware of this. It is still a little relevant. Sorry, I said YouTube. Meetup. I had YouTube on the brain. Meetup page. Still very relevant in the fact that we can use this as a way to broadcast when the speaker info is published, and also act as another way to be able to corral and pool all of our audience for some of the items and some of the nights that keep going forward as well. So I'll just jump now into our code of conduct. So, anti-harassment policy still applies online. So we've got to make sure that you're aware that we do have this code of conduct. It's published up on brisjs.org, and hopefully that makes a lot of sense for you. Do check it out. Also, if you are looking at doing a talk, that would be amazing. I'll be your best friend, because we absolutely always need talks, and we'd love to try and schedule these a few months ahead, hopefully. And that way we don't have a run out of speakers, and make sure that we can organize these things for you. If you just really wanted somebody to be able to come forward and present on a particular topic, feel free to submit a talk request as well. So you can pop that in there as well and say, look, I'm not prepared to cover this particular topic, but maybe there's someone out there who can, and vice versa. That will show up on brisjs.org as a suggestion of something that people could present with. If they're stuck for ideas, but really want to get out there and contribute to the community, they can have a look at those items and see what they could do a presentation on. So we coordinate all of these issues, all of these talks through our GitHub issues. And you can always get in there and have a look at some of the ones that are tagged with the upcoming months and with the schedule confirm, as we try and the logistics of getting everyone lined up for a specific date. So if for any reason whatsoever the meetup page is not there and not ready, you can always get in and sneak in and have a look at our organizing from here, and plain as day, open air, and have a look at everything happening there. So that's the same place where your talk contributions go. Raise a new issue in there and we'll tag it appropriately as well. And we can jump to some of our other socials. So you've obviously seen this is our YouTube. We've got a Facebook and our Twitter as well. Twitter's the active one where we're doing a lot of announcements. But if you'd like to contact on Messenger or anything like that, especially if you're interested or asking questions about doing any speaking, that's connected as well. There's brisjs.org to try and pull those things together as well. A few links on there as well. And if you're in need of a job or you'd like to post one, there's some details on brisjs.org under jobs. So there's a little job board that will be driven from the GitHub posts as well. There's a few new ones on there, I believe. Okay, so tonight, without any delay, let's go straight in and sit and have a chat with Andrei, who's talking to us about observability. So all the things you wanted to know but were scared to ask. So just welcome you to unmute and say hello. How are you doing?
Hey, Kevin.
Welcome, welcome. Thanks for joining us tonight. I'll let you take it away.
All right. Okay, let's just make sure that we can see the screen.
We certainly can.
Cool. All right, let's get into it.
Thanks very much, mate.
No problems. All right, so this talk will kind of cover three big areas, and we'll spend a bit of time in each area. So what is observability? What I'm going to try to do here is really talk about observability from a non-vendor kind of trying to sell you software. So there'll be a little bit of theory, but hopefully we'll get over it. Sort of talk a few things about if you were going to try to do observability, some of the things about implementations. And at the end, I've sort of put a few really, really good resources that I like, and then hopefully we'll have a Q&A. All right, about me. So I work in DevOps or site reliability engineering or platform engineering, as it's slowly becoming known. So I worked in Brisbane with startups, scale-ups, and very large established companies. I've got 2 dogs, and they really have promised to behave themselves, but we'll see how that goes. So if you hear barking, I do apologize. My training is in sort of the scientific method, so I do really, really like the application of scientific thinking to problem solving, and using data-driven decision-making. This talk, I've done my best to try to distill a lot of knowledge, but if I haven't done so, hopefully you guys will get 1 or 3 insights. Can we just do a quick sound check, make sure we're still okay before I go too far?
Perfect. Absolutely cool. Fine. Loud and clear. Thank you.
Cool. All right, so how this presentation came about is Ashley reached out to me on LinkedIn, and he kind of said, hey, how can I understand this observability trend? I'm seeing a lot of this, but you can get very bogged down into the details. And I kind of thought to myself, you know what? I know what you're kind of after, but I just can't really think of anybody that gives kind of a good overview. So I kind of thought to myself late last year, maybe this could be a good talk. And then Ashley almost immediately came back and said a talk would be awesome. So here we are. This talk kind of combines a lot of experience I've had with observability over the last probably 3 years. So some of the experience comes from things like books. Observability is a fairly detailed topic. There's even a book on it. So that's sort of, it tells you how difficult it can be. Then there's a few things like vendors that I've been following that sort of have very, very good practices. So what I've tried to do is kind of grab all that and kind of distill it into key concepts. So kind of following the concept of, if I can't break down the key concepts well enough, then I probably can't explain it well enough, or I'm trying to sell you software. So the first sort of classic thing that I see a lot online is the way people define observability is by comparing it to monitoring, which is an okay approach in my opinion, but somehow I don't think it's actually useful, because then you kind of get into this whole, well, should I be using monitoring or should I be using observability? So what we're going to do is we're actually going to take a step right back and kind of take a journey as to why observability is kind of becoming a movement that a lot of people are interested in. So a lot of you guys are in software development. I'm more in software reliability, but reliable products rock. Reliable products are a combination of happy customers, happy business, and happy engineers. The two things that I think observability really helps is happy customers and happy engineers, because hopefully it makes it easier for us to deliver reliable software. So we'll talk about some of the aspects of observability that let us do that. We're going to spend a little bit of time on this particular table. So if you take at its core a reliable product, there are two components of a reliable product. There's a system, which the way to think about it, it can be a cloud, it can be a server, and then there's software. And I think fundamentally those two bits, even though we're trying to combine them more and more with DevOps and other sort of strategies, those two elements are fundamentally different. So for example, AWS, which is a cloud we use quite a bit, they release their services, but they don't release the service every 2 days. They don't make significant changes to the services every day. And if they do, they usually give us a good 9 months notice. Whereas the modern software development house, or the ones that are still standing, will be standing in the next few years, kind of move to this daily commits. It's the value of the business is not running software platforms or running Kubernetes clusters or running clouds. It is really about the software delivering value for customers. And that's really where observability differentiates itself from monitoring. So I like to describe what's called use case driven observability. So like a lot of times, what I'd like to do is take a step back, and rather than trying to get into things like fear of missing out, or we're doing this or we're not doing this, kind of talk about what is it that we want to do. So I believe most modern teams, we want to run reliable products and remove any undesired behaviors that may impact customers. So that's really our motivation, whether you're on the SRE DevOps side like myself, or whether you're writing the code. I think we all want to have reliable software because it makes life a lot easier for us and makes customers give us money. How can we do that? We can use monitoring. I know a lot of software companies still think monitoring is the way to do that. I would argue that observability to investigate and dismiss potential causes using a hypothesis approach is a much better approach, because not only does it sort of allow us to be more flexible and more exploratory, it means that we don't have to sort of rely on troubleshooting gurus or experts that may not be available or may choose to move on. And what's the process of observability? We kind of use queries and visualizations to kind of back up our thinking. So if I think the reason why we're having a slowdown is because service X is misbehaving, I can prove with observability that it was, doing this, was doing that. So, that's a good concept, but how do we actually break it down? So here's a couple of examples. So let's just say service Y seems to have become slow. So our product manager or our engineering manager goes, hey, customers are starting to go, starting to say that the login screen is taking forever. So as a DevOps engineer or site reliability engineer, the kind of hypothesis about what's going on that I can form in my head is a new release has somehow slowed everything down. A supporting service has resulted in longer calls, or infrastructure has changed somehow. We've changed something in the infrastructure and now everything's running slow. And the kind of observability questions that I would ask is, can metrics confirm a slowdown? Has there been a release, or has there been some other change? So these are the kind of things that I would go, hey, is it actually provable? Or maybe we're barking up the wrong tree. And that's where I think one of the key concepts of observability comes in. We don't assume we know the answers. So another sort of use case driven observability, service is returning an error code for a particular query. Once again, we can kind of form a hypothesis, saying things like subservice is not working. The service itself is wrong. So there may be a release that, makes some assumptions about pounds versus US dollars. The query timed out, the payload was wrong. And once again, we can ask simple questions of our system. Did the service invoke a dependent service? Did the service raise an exception in the logs? Is that in the payload valid? So then, as I described before with the use cases of observability, so one of the key things that one of the key tenets of observability is really us understanding the system from the outside by asking questions about that system without necessarily knowing how it works, which will make sense in a minute, but that's basically a key definition. And observability itself comes from industrial process management. So, if you imagine something like a cheesemaker that's got big vats you can't see inside, you rely on your tooling to tell you what's going on inside those big vats. A typical explanation for the rise of observability has been that we're moving to microservice architecture, and that monolithic architectures, when everything was on one server, you could monitor CPU, and CPU was a good indicator of failures coming up. Whereas in microservices, you may have lots of services, and things like CPU don't really matter anymore. I think there's a few other sort of key trends in the industry. So the first one is we are really getting better at shipping software quicker. So rather than having planned releases once a month or once a quarter, a lot of companies are doing these daily releases or maybe 3 releases a day. So trying to coordinate and kind of understand what's going on is an anti-pattern because teams are now operating autonomously. So we don't get together and go, hey, what's changed? Hey, should we put in some monitoring for this and that? It just happens. And also part of those is number 3, the shift left movement, which means, part of the work I do is enabling the developers to provision their own infrastructure. So a lot of the time as a site reliability engineer or a DevOps engineer, I might not even know that a particular microservice has started using a different service bus. Another evolution is software outages are basically becoming more visible. So as companies, we do status boards, we do postmortems that may be public and less desirable. Configuration is usually a leading cause of outages. We've seen far less of this fixed by gut or support gurus, just because as we start making these complex systems, there's nobody who can understand, the inner workings of messaging buses, databases, NoSQL databases, load balancers. So having things which give us an idea where the error may be are becoming more and more useful because it's just too hard for one person to have a mental model of how the entire system works. The other trend is, we get encouraged to remove root causes rather than trying to monitor them or patch them. So one of the classic things was like, all right, well, we'll just do a cron job to restart. That sort of thinking is going away. So we spend a lot more time trying to remove the root causes. And if we can't identify the root cause, then removing it becomes hard. Work from home, for me personally, has been also another reason why companies I worked with had moved to observability. So we're no longer sitting all in the office. There's no big dashboard TVs giving us overview status. And a lot of the times that I have to intervene during my working hours, it's because somebody's having a problem. So I'll, go into a dashboard and saying, oh, there's a problem. It's not the way I work. And I think, there's an evolution of the way we think about how we maintain our systems. All right, just quick sound check again, and probably the last one.
No, you're definitely there. All good, man.
Cool. And some of the proof of this is basically the DevOps acceleration. And we can see that we've gone from sort of like medium to a lot of elite and high organization, high performing DevOps organizations. So a lot of the investments being made in the field, which means that kind of trying to stick in monitoring dashboards is not really going to be suitable. Right, so what's another principle of observability? So we've discussed the fact that observability itself doesn't assume that you know what's going to happen. So you kind of trying to deduce the system state from the signals that it outputs. The second thing that observability kind of says is that debugging from first principles is a core capability of observability. So first principle is a basic assumption about a system that was not deduced from another assumption. Now, that's a bit of a mouthful. So here's kind of a simpler explanation that I kind of use. So the two first principles I use when I troubleshoot problems that come up in our software or our stack. The first one is what's different. Why does the software behave well in some situations but not in others? And the second one is what's changed. What have we introduced that maybe is changing the behavior of our software? A couple of sort of applied examples. So in the current company I'm with, we run 6 environments. At one time, we had 3 of them working and 3 were not. When we compare the 3 environments that were working and were not, we found that the 3 that were not working were running a tool called telepresence, and then we kind of figured out there was something funky going on there when we removed it. So that's kind of thinking about it. What's different? What's changed? Our reliability went from quite high to quite low. We confirmed that we're losing sort of SLI, SLO, that we're burning our budget. And we kind of figured out that we made a change to the service mesh and it didn't quite work as we expected. So it was dropping sort of things. So we went back to the drawing board there. So those of you who kind of like sort of scientific principle, there is the core analysis loop, which kind of goes, if we're trying to find a problem and we have data, how do we go through the process of troubleshooting? So it basically says, grab the data, visualize things that are different, search for common patterns, and try to see if that particular thing has caused it. Now, most people kind of start with observability with what I would call the signals or the things that give you the indicators of something wrong. So the model you see, I actually quite like. It's called Temple. And I've kind of highlighted the 3 sort of what I call original OGs. So if you read things like observability in distributed systems, you would probably have heard of traces, logs, or metrics. If not, logs and metrics should be pretty self-explanatory. And we're just going to talk about these signals a little bit through the next few slides. Those of you who haven't seen a trace is essentially basically timed events across microservices. So what it allows you to do is basically collect everything that was going across each time you swap, whether it's an async or sync call. And you can build up a understanding of for every request, you can build up an understanding of what was going on at each stage of the request. Profiling. So last year, OpenTelemetry and other sort of people that are interested in observability have kind of said that profiling may be a useful signal as well. Those of you who haven't seen profiling before, it's this thing on the right here. So basically what we're trying to understand is our function or our program, where does it spend most of its time? And if we can compare that before a release and after a release, and we see significant increases in something we don't expect, we can go and have a look if it's a new library that's all of a sudden got a memory leak or if it's something else. So profiling is quite a useful signal in terms of telling us what's changed. Events. So events are emerging slowly as a very, very useful tool in its own right. And what it gives us is context. So an event, the way to think about it is just a point in time metadata sort of thing. So events happen or they don't aggregate, they don't have any extra context. So here's a good example of a representation of events on the timeline. And what will happen is, things like releases, things like CI/CD building artifacts, our CI/CD system pushing things, Kubernetes. If we can aggregate all those and build timelines, we can get quite a good idea of what's happening in our system or what's not happening in our system. As I said, events are becoming another sort of signal that people are finding very useful. And there's even a standard called cloud events that some of the major vendors support, which basically standardizes in the way that events are transmitted. Exceptions is the last one. And I think the easiest way of thinking about exceptions is it's either an error log, so if it's a log of type error, or it's a stat trace. So basically exceptions tell us, something's starting to change. And, there's some good tools that kind of take exceptions into account if there's a rise of exceptions. Or if there's new exceptions, that can help us to understand what's changed, and it could be a software induced or it could be something else. So when we're talking about these signals, so the temporal signals, one of the more important things to understand is that when we collect these signals, if we are trying to describe all of these signals the same way, we're probably not going to get a good idea of what's different. So, which of these sort of more expressive, if we describe everything as a hammer, we're not really going to be able to, differentiate versus something like on the far right, where each tool is a different tool and we can sort of describe it by length, by purpose, whether or not it's a long nose plier or a short nose plier. So that's what I'm trying to say there. In order for us to do that, our traces or metrics or logs and those other things, any of the signals we collect should kind of have two things: dimensionality and cardinality. So dimensionality is about how many extra data points we add about let's just say a particular log. It might be useful to know that, service X is failed, but is it running a particular cluster? Is it getting information from a particular service? Is it in a particular region? And cardinality, which is the second thing, is how unique. So if every one of your extra bits of information is exactly the same, then you don't have high cardinality. So you're not going to be able to differentiate each of the signals. A quick example is, let's say we're running an e-commerce shop, and what we need to do is we've got 3 types of customers, and then our boss says, hey, our government customers are complaining about checkout because it's just taking too long. If we just have a technical context for all of our events or all of our signals, what can happen is that we can't differentiate government customers versus our regular customers versus our ad hoc customers. So one of the things we can do to increase the uniqueness of all of our signals is add some extra context, which can be a business context. So things like spend, customer type, and order ID. And then we can even do that a bit more. We can add an approval workflow, and that might show us that, hey, wait a minute, government customers are significantly slower. And the reason why they're significantly slower is because A, they have more steps, or one of the supporting services is taking longer. So by making those signals unique, as unique as we can actually use those things to detect those differences. So, and essentially what I'm trying to say here is it's good to have a combination of technical and business context in your signals, because that can help you to identify what's different. A really, really good example of kind of troubleshooting by what's different is a product from a company called Honeycomb, where they kind of allow you to, what they allow you to do, if you have instrumented your signals properly and you have a lot of metadata, what you can do is you can tell it, hey, here's a good series of events, here's a bad series of events. And using that kind of automatic logic, that can tell you things like, wait a minute, all the bad events have this particular target. Let's go have a look at that target. So the ones in orange are things that have changed. So you can kind of go, okay, so all of the bad events are happening in the cart, and they're happening in a particular target as well. So that really helps you to narrow down what's different, and hopefully you'll be able to go and figure out. Propagation. So we've talked about, it's really, really good not just to collect signals, but also to collect metadata around them. If you've got lots of different steps through your microservice, what you want to do is make sure that you go and pass the information along. So basically, one of the other desirable properties of a observability system is that any attributes that you add to your signals, that you pass them along to all of your other dependent services, so then you can differentiate those dependent services as well. The last bit we're kind of going to talk about is correlation. So correlation is a relationship between two or more things. So the reason why that's really important for observability is it allows us to use different signals and kind of stitch them together to get a much better understanding of what could be causing, either a slowdown or an issue. Most common correlation is time-based. So we kind of go, hey, if we see a whole lot of errors and we're seeing error traces, let's have a look at the logs. We can also use trace IDs and transaction IDs and be very specific about correlations. So here's an example of correlation. So that's just a more practical example. At the top here, we have a trace. And what we do is that trace has a unique ID, and then we can use that ID to find any logs associated with that trace at that time. So those two combined gives a very, very powerful view of what's going on, not just with the logs, but also the tracing. And combining those things mean really, really useful in troubleshooting, because what it means is that we're not having to go to different systems to correlate information. We can correlate up information together. So here's another example of two different signals being correlated. So this is a trace. And then what we're doing is for that particular trace, we are embedding a profile. And what that allows us to do is, kind of have a look and go, hey, this trace is slow. Oh, wait a minute, this particular profile, this particular operation is taking a long time. We're not expecting to be taking that long in this particular function. So once again, having signals in isolation is useful, but being able to correlate different signals together gives us very powerful troubleshooting. The only thing I would say is when it comes to signals, correlation doesn't always mean causation. So if you want to have a bit of fun, go to the link at the bottom and you can see some examples of things that seem to be correlated but have nothing to do with each other. All right, so that was hopefully a bit of theory, but we can kind of summarize it down. So the first principle is observability is much better suited for troubleshooting complex systems like software and more revolving microservices architectures. So the second core principle of observability is asking questions rather than thinking we know answers. So asking a question means that we can't set up monitors, we can't set up alerts, we can't set up things that potentially might cause our system to go down, because as our system evolves, maintaining that knowledge and maintaining those just become practical. Whereas having signals and collecting signals and asking questions and querying the signals when things come up becomes much more sustainable. So we create signals. And then the last bit of observability, last core principle really is, which we talked about for the last sort of 5 minutes, is if we want to be able to ask questions of our signals effectively, we need to make sure they have high cardinality and dimensionality. Otherwise, we're just not going to be able to differentiate or find things that are useful. At a high level, this will be a typical journey for a company adopting observability, and a lot of you guys are probably either somewhat on the way there or maybe looking at it. So we instrument code, and then we kind of choose which telemetries make sense for us to export. So it could be metrics, it could be logs, it could be traces. You might just start with traces because you feel that that's the biggest bang for buck. And you put all those things into a backend data store, and then you use some kind of tool to analyze them. So this next bit is going to be really about what some of the pitfalls are and what some of my thoughts are about tools that we can use to kind of analyze and make observability a practicality. Because I think this is the value add when we can actually use these tools to troubleshoot and get insights. That's our true value add. It's not doing what I would call the plumbing. So the first bit is, if you want to instrument the code and export telemetries from the code, you really can't go past OpenTelemetry. That particular project, I think it's the first, it's number one project on CNCF, which is the Cloud Native Computing Foundation. And they're the guys who look after things like Kubernetes and those other things. So it is very, very much an emerging sort of, well, not emerging, it's a technology stack which solves a whole lot of problems. And the second thing which it doesn't lock you into vendors. So you can kind of go, look, I'm going to try vendor A, and then I'm going to try vendor B later on. And I did a talk on OpenTelemetry, I think this time last year. And even since then, it's actually come a long way. So if we go back to this for a minute, if you're kind of looking at these two, OpenTelemetry will really solve that for you. So there's no really need to reinvent the wheel there. The second thing we're sort of going to talk about is some of the other things that I see in the industry. So as I said a few times, avoids dashboards. A dashboard assumes you know the answer, and prefer investigative toolkits. So I'll give you a couple of examples of what I think a good investigative toolkit is later on. Vendors tend to specialize in an area or support multiple signals. So when you're playing around with vendors or you're experimenting with vendors to help you with your observability journey, just check whether they support, support multiple things like traces, logs, and metrics. I think that the three key ones, or whether they just support a subset of those, because it can assure you of efficacy in troubleshooting if you just get to work with one signal. Plumbing, so storage and propagation, is not a value add, I don't believe. So cloud vendors in a lot of ways make sense. So cloud vendors where you can set up an OpenTelemetry collector and push the data to them, and then they sort all that out for you. That's becoming more and more common, and it's becoming cheaper and cheaper to do that. So I think that's really, running your own stacks is not something that I think a lot of companies would use, but yeah. So evaluate different vendors. Don't assume one vendor will meet all your requirements or all your team requirements. So one of the discussions we're having at the moment about observability at the company I'm at is developers don't necessarily want to learn query languages. And some of the more advanced stuff we want to do, like, analyzing releases and slowdowns, the tools that make sense for developers to get answers are very different to the tools that make easy for the SREs. So don't be scared to use multiple vendors, because different teams may need different capabilities. And I don't think there's one vendor that can fit all the requirements. And in order to be successful with observability, you really need to start thinking about a debugging and investigative culture. And if you think about, the bit of the slide where it kind of says, how would you ask questions? What you'll find is tools that don't let you think that way will naturally weed themselves up. Avoid specialized vendors. So vendors that go, hey, you have to use our SDKs to instrument your code, because what happens is that a lot of the times you can't push that data to other places that may be useful. And the other one is, think carefully about retention. If you are doing this kind of like what's different, what's changed, do you really need to go back 6 months? Given the things like, the release velocities we're using now, I don't think you need to have more than 30 days worth of storage, personal opinion, in order to have an effective observability platform. So this is just a list of vendors. So on the left, there are some vendors that I would call kind of like they're full stack vendors. So they're vendors that will support multiple signal types. That will allow you to query the multiple signal types as well. So kind of a good, hopefully some familiar faces and maybe some different faces. On the right are some what I would call specialist vendors. So for example, Commodore and Robusta. The reason why they're kind of specialists is you really do need to have Kubernetes to make them work, and they focus on specific parts of Kubernetes, so things like events and metrics. So they really only talk to 2 of the signal types, and they ignore things like traces and logs. Pixie and Pyroscope, once again, around, Pyroscope's really around profiling. They're not interested in doing anything else. So, excellent at profiling, but not necessarily allow you to then go, well, how do I integrate that with tracing? And as you saw from the example, they much prefer to be good at profiling. Aspecto, tracing, Greylog, and, some of those other ones where they're really just focused on one of the signals. And it may be that that particular signal is complex enough to analyze that there is a value add. But just think about in the observability stack, whether you would like to have the correlation or whether you can troubleshoot effectively with just one signal. So, yeah, basically the last bit is actually about complexity. So, one of the things that we've done really well is traditionally we would have had to, sort of even 2 years ago, you would have had to use Prometheus library to do metrics. You may have to use something like Sentry to do, to do your logs, or Raven to do your logs. I think that's the NPM library. You may have had to have something like Jaeger, the equivalent of Jaeger and Node.js to do your traces. So it's been one of the things that we've done really, really well is we've actually removed the need to have specialized telemetry, but we are still potentially inheriting the sins of when we want to analyze signals, what we want to do is use kind of a common query language rather than having to learn a language for every signal type. So, there are some stacks out there that, to analyze logs, you have to use something called logql. To analyze metrics, you have to use promql. And what that ends up is, if you think about your observability interface, it ends up being like that plane at the top where every single thing, every panel, everything you touch is very, very specific reason. I think, the way to look at observability interfaces is much better at the bottom, where you kind of have the information and you change the way you use the information based on what you're trying to do. So it doesn't make assumptions on what you want to do. There are different ways of sort of manipulating it. And that's the point I'm trying to make. Good observability vendors, what really differentiates good observability vendors is that they will let you chop and change signals in a consistent way. So what does that kind of look like? So for example, Honeycomb, you can see that basically they use, their interface is based on, you want to visualize something, you want to filter something out, you want to group and limit. So that's an investigative dashboard. So that's about asking questions. It's not about making assumptions about that you already know that your CPU level spiking causes things. It's about going, hey, I'm trying to find what's going on in my system. Here's the things that maybe the cause. Datadog, also another really great example of, here's your different signals. You can kind of go and see, you group them. You can add overlays. You can have markers, which are basically events. So you can kind of build that kind of thing going, hey, we may have had that release. So you can, at any given time, you can build a quick visualization, which either proves or disproves your theory. And the key difference between that and the dashboard is that because you can build these things really, really quickly, you can prove or disprove, and then maybe you can throw away, or maybe you can pin it as a common thing, but you're not required to know all the answers in advance. Or you're not, the other difference here is that because of the kind of prompts that you get as you enter the data, you're not having to mentally remember how to build a dashboard. So it can be very frustrating when you're troubleshooting to go, oh, how do I change a dashboard, or how do I create a dashboard that looks at different aspects? So that's why I think these investigative interfaces are a lot better. Cool. So in summary, kind of combining the first principle, which is a lot of theory, and the second thing is what's in the industry. Let's kind of sort of make sort of key summaries. So the first one is observability has a cultural component, which is very important. I don't think you can, without the investigative culture and asking open questions and sort of having that practice of go to your traces, go to your kind of build those queries, see without making assumptions up front, I don't think you'll ever get a benefit from the observability tool. Identify things that monitoring can't answer, and think about the signals that may answer those things. So one of the processes and evolutions we've taken is you need to start somewhere with observability. So even if it is with just traces, that's enough. And then what you'll find after a while is traces don't give you the answers. So then you might want to go, okay, let's make an investment into metrics, or what other signal makes sense. And then you can kind of take it step at a time. I think trying to make your system observable from scratch one is impractical, and you probably won't get the engineering or the senior management buy-in. So as I said, like find that one thing that's a problem, and then, tracing tends to be the first thing that really helps. And as that helps, then, going, hey, you know what, at the moment we're skipping between tracing and log interface. Wouldn't it be nice to have them correlated? Then you can build on that investment. So with the reason why I kind of spent a lot of time in the first bit describing a lot of theoretical components is there are a lot of observability, and I use the quote marks, observability platforms. It's hard to evaluate without kind of going what the good properties of observability are. So I think having that kind of mental model of what a good observability platform should do means that you will be much wiser, hopefully, in kind of, or much better informed in making your decisions on investing in observability platforms. I've covered this quite a bit. OpenTelemetry really does simplify your ability to instrument your code and get that signal data to somewhere useful, whether it's vendor A or vendor B or a combination of vendors. Number 5, dashboards. Dashboards are things that natively come to us mentally, but I think investigative interfaces are much better. So even if you have to build a quote unquote dashboard, just think about, is this thing open enough for me to be able to ask multiple questions? And if the dashboard vendors don't support that, then think about how can I present information in a correlated way that people can use that to troubleshoot, rather than present things that I think might be causing the issue. So that's where, for me, that's the comparison between investigative interfaces and dashboards. In most cases, SaaS and cloud vendors are very good in terms of features, price points. And as I said, building observability platforms like, reliable observability platforms is hard. And the second thing that, you can spend a lot of time on focusing on the plumbing, not getting the benefits, and then your sort of stakeholders going, no, it's not useful. All your internal sort of customers, like your developers, going, look, we're not getting any value out of this tracing because it's either unreliable, or we can never log in, or we don't understand what this trace means. The second to last one is, best practices how vendors sell software. I like the idea of good practices, and I think what we need to do is actually distill good ideas from vendors and decide if they're value add to us. So if a vendor says you absolutely must have profiles in your traces, but you're not a company that ever uses profiles, or you're not a company that has developers that would think that way, then you can spend a lot of time building something that isn't necessarily native. And so that's what I'm saying, just because OpenTelemetry says profiling is a good signal, if it's not something that you've currently ever heard of in your team, or your developers never heard of it, or, it may be worthwhile investigating, but I wouldn't spend a lot of time focusing on things that don't allow you to do that stitching. And the last point is monitoring is not dead. I'm definitely not saying go and rip out all your monitoring or all your alerts. I'm just saying, think about monitoring for, monitoring for keeping a track of your known systems. So things like S3, an S3 bucket, will either fill up or it won't fill up, or an S3 bucket will slow down and won't slow down. So those kind of system things, I think monitoring is really, really useful still to rule out those as potential root causes. Where it kind of falls short is if we try to use that monitoring approach for a system that evolves quickly, may have lots of unknown components, and we're kind of going, why can't we see that? And an example of that was, we had a file system that kept getting full, but it was the way the code was written that was the issue, and no amount of monitoring would ever give us the answer. So that's why I think a combination of monitoring and observability can make those reliable systems. And I'm definitely not saying throw out your monitoring. Cool. So then resources. So what I've tried to do here is essentially break it down. There's a lot of good resources on observability, but these are the ones that are kind of broken down into, depending on how you like to consume your information, you can kind of get an idea of some good resources. So if you're an ebook reader, Observability Engineering is just pretty much the Bible for observability. It was released last year, and it's free, so you don't have to pay for it. It will give you a lot of ideas and help you with a lot of assumptions you may have. Is it observable? It's a YouTube channel, really, really good. It's very much focused on one very specific technology and a very much deep dive into specific technology. So if you're interested in specific technology and he kind of covers it, it's an invaluable resource because it can be up and running in probably 2 hours, depending on what you're trying to do. Podcast. Open Observability Talks. So the guy who does that, he's part of the CNCF, and he's a major contributor to a lot of the thinking around observability. Weekly newsletter. So if you just want to catch up once a week, lead.news. The ones that are probably going to be, I'm assuming I'm talking to a lot of developers and people who like to get their hands dirty. So there's a hands-on training from a company called the Spectre, which is about 8 hours, but there are two really, really good things about that training. First of all, it's free. Second of all, depending on what you're trying to do, they will cover a very simple implementation to a very, very customized implementation. And the third thing, it's all in Node.js. So it's very, and TypeScript. So it's very, very easy for JavaScript developers to follow, which means that, if you are really kind of going, hey, we're just kind of to dive in and have some sample code and have a look at a few things, I can't recommend that highly enough. It's a very, very well put together course. Sample code. So if you want to just see some sample code on how other people are doing it, or how best practices are doing it, there is an OpenTelemetry special interest group. and their job is basically giving demo code to developers so the developers can kind of see how they do things and get those best practices as quickly as possible. So those two are probably really, really useful. Then the blog, Honeycomb has a really good blog on general observability trends. Conferences, I like attending KubeCons. If I don't attend them, I usually wait a month after. The reason why KubeCons I think are the best for observability is observability, it's probably 25% a quarter of the vendors at the KubeCons that talk about observability related concepts. So there's a lot of different tools and you can get a lot of different ideas. And the last one is basically there is a Slack channel. If you're just kind of interested in what people are talking about, there's a lot of people exchanging ideas. How would I go about this? Cool. Last bit is attribution. So I've used quite a few icons from Flat Icon, and I've also added links at the bottom if I've borrowed ideas. I'm happy for people to take parts or rework the slideshow in their own thing. Just respect the original authors and abide by their rules of content sharing. That's why I've got a little bits at the bottom. Just not all of that stuff is mine, so I have to attribute. And then we can get to the questions.
Yay, fantastic. Thanks very much for that. Okay, let's have a look at some of those questions. We've got quite a good stack of different questions here that jumped out. I was just also checking the YouTube studio for the chat, and I'll just make sure that I can move that one over. Okay, now I think I've got them all. Alrighty, let's go through and have a look. I'll just pop us back on as, hang on a minute, just face to face. Now we can have our heads side by side on the video. So yeah, I'll start from the top down. Looks like there was a few upvoted ones here, so that hopefully helps us tackle the first one first. So the most upvoted one here is, how can we find degradations before our customers?
Yep. So we think this talk was very long, so there may be a follow-up talk on SLIs. So when I initially did this talk, there was going to be a bit about an ecosystem of observability tools. So I was going to talk about things like K6, which is load testing, using SLIs, SLOs. The talk just got too big and I kind of had to chop. So yeah, I mean, if you SLI, SLO, so that's service level objectives. So on the third slide, there is a book that I kind of talked about, and that's basically what you would use. That's what we're using, kind of going, what's important to us, and if it's degraded, then we're going to care about it in that release cycle. Otherwise, we're just going to let it through.
Yep, absolutely. The next highest one here is, do you see the value of running end-to-end tests against production environments to help highlight any changes being generated instead of waiting for a customer to hit it? So it's in that same, let's find it before our customers vein.
You're not always going to be able to do that. So like we implement observability because you can spend a lot of time. So release engineering is a separate discipline, right? So you can spend a lot of time in the release engineering trying to not have bad releases. I think invest in observability, have like-for-like environments that you can test against, and then use observability as a tool to then catch those things. And as I said, like SLI, SLO will give you indicators, but not always. And it's an evolving thing. So I don't think you could sit down and fundamentally map all of the breaking things. I think what you have to do is you have to kind of take a step back, focus on which aspects of your service, which aspects of your service are really important, and then make sure you have SLOs around those, because otherwise what happens is you kind of get the negative thing is you kind of go, okay, we're going to spend so much time on release engineering, and that's going to negate that thing. So yeah, it's writing fast with scissors, and I think observability can help with that in combination with SLO, but it's probably not the way to think about it.
No worries. I will just mark these so I can get to the next question. This one's very straightforward. What's a good library to use for profiling? We host on AWS.
Okay, so that's I haven't done Node.js development. There is so for profiling, there's two ways of going about it. Okay, so there is a company called Periscope, which I quite rate, which basically, and I'll stick them to YouTube chat. Basically, they have libraries, but the biggest advantage is they can push your profiling data outside. So for me, that's quite desirable. The second way, which I see people adopting profiling, is a standard called pprof, so PPROF, which is a generic standard. So I'm sure there's a Node.js pprof library. What happens is you expose an endpoint like you do with Prometheus, someone scrapes that pprof data and goes there. As I said, I don't know which Node.js libraries would do it, but I will stick some examples in the YouTube because I'm sticking around for the next time.
Exactly, yeah. There's already a pprof npm package, at least to be able to interact with it directly. So there's definitely going to be a few out there. Yeah, thanks for that hot tip. So the next one here is, do you have any tips for product teams? How can we help product managers and other non-technical stakeholders see the benefit of investing effort in observability?
Sure, yeah. So that's so the way you talk to people. There's a few, as I said, like this talk was already too long. I did have in my mind some of the other disciplines which SRE talks about. So one of them is postmortem. So there's a concept of mean time to resolution. How good are tools at giving us? So if you think about an incident, if we can get to the answer really quickly, that looks a lot better, and we can repeat it really quickly. That looks a lot better. So that's always a good point. How long does it actually take us to find a problem? And when you do your postmortems, if there is that postmortem thing, that could be a good case for doing observability, because it should help you to narrow down the problems. Essentially, I would say the thing about observability is reliability. So if you're not measuring reliability in any way of your software, like not in terms of SLAs, like don't think about it as uptime. Look at reliability. I'm feeling that there's going to be an SLA talk next month. Look at reliability as your user experience. If that degrades and you can't recover quickly, what the Google SRE mentality will tell you is you should spend the rest of your sprints basically fixing that bug. So that's how you kind of go, and then you kind of go, how do we detect it quicker? So really the key thing is the balance between going fast and being reliable. And that's where kind of I think observability plays an important part, because it can help you detect those small changes which break hopefully quickly, because you're asking open-ended questions and you can kind of go, we're seeing this, or it's this particular region, let's go investigate and then find it, versus, it takes a long time. But I think observability itself, I would start with something as simple as tracing. If you can get an understanding of how your request, if you can't get an understanding of how your request is spending its time throughout your services, definitely invest in tracing and show a product manager that and go, hey, here's the changes. I think businesses buy into that. And as I said, it's, there's also, download the Observability Engineering book. There's an entire chapter on how to sell it to your managers. So that's probably the advice I should have given. But yeah, it can be a bit of a journey. And as I said, don't try to like bite off the entire thing. Just kind of go, what's that one thing, that pain in the bum that keeps us up?
Yeah, absolutely. And I think this question is probably coming out of folks looking at how to translate or transition from monitoring and alerting into sort of an observability mindset. So the question is verbatim, where is the role for alerts on some of these things?
I should have done this. All right, so I'll do it in 2 minutes. I think alerts, if you get alerted about something, right, the litmus test for me for a good alert is, can I do something about it? Can I make an actionable change when I get an alert? If I get an alert that says 500 errors increase, right, or let's just say 400 errors increase, what can I do? Because 400 client-side errors, is it actually worthwhile having an alert? So I think if you've got well understood sort of patterns and alerts, concept of monitoring, if we move to observability, like an alert may trigger an investigation, but generally we don't use any alerts and like our systems sort of run okay. And I think, yeah, I haven't seen any good sort of, like you wouldn't use an observability tool to kick off an alert, because the reason why you're collecting that data is because that I think observability goes hand in hand with SLI, SLO, and I'll just post a link as well in the YouTube chat about what I'm talking about. Basically, what you say is, rather than trying to deal with every single thing, you have an error budget. You can have so many failures in a month. Once you start exceeding that, then it's a problem, and that's kind of your trigger point to go investigate. So it's sort of a different mindset. And I think, yeah, with our observability stack, we purposely didn't set up alerts because we're using SLI, SLO.
Awesome. The next one that comes up is, would you say monitoring telemetry changes significantly, monitoring telemetry changes significantly between monitoring and to now supporting observability? So the concept of going through and having telemetry over your application, I presume here. I guess it's all still based on logs is part of that question.
Yeah, so I think this is, observability, and especially that temple model, the way you look at it is kind of a mindset. So like if you look at monitoring is measuring, and then you have thresholds, and then you have alerts, right? So that is the premise of monitoring, and that lends itself quite well for known things, right? So if your load balancers aren't, are experiencing high CPU, you can kind of go, okay, well, let's do something about it. And you may be able to do something about it. You may be able to spin up more things. The question I would ask is, why is that not automated? But that's a different thing. So I think monitoring fundamentally, like if you look at it as a concept level, monitoring is you get an indicator, which is usually a metric, of something that you know that's going to fail, and then you act on that. Observability is you have something wrong in your system, you've got these different bits and pieces, and it's not just logs, it's not just traces, it can be a combination of both. How can you use those signals and that information to give you a picture of what's wrong? So that's the difference, I think, is, and that's where I think the industry is kind of, monitoring kind of came along, I think, when we had monolith applications where there was that close correlation and there were sort of that simplicity. But I just don't believe you can know all the unknowns, basically. You can't know everything that's going to go wrong, especially given the velocity and the ability of choices. Like, you're not going to know everything up front to be able to. It's probably somebody's full-time job just to create monitoring dashboards and remove things. So there was a good sort of post that I saw this morning is, kind of, you can't get a system overview with monitoring. Many people have tried. I think you can use monitoring to give an indication of your hardware platform in certain things, and that can be useful. But
yeah, absolutely. I guess that leads reasonably well into the next one, which is, what are some developer-friendly libraries that can support generating lots of good events and signals in the API services under development?
Yeah, so that's OpenTelemetry. So OpenTelemetry has a Node.js library, and that Node.js library will support. So I did talk about this, actually, the simulators this time last year. So the Node.js library will support traces, metrics, and logs. So basically, have a look at that, and it's all fairly well documented. If you want to, like, if that's your question, what I strongly suggest is you go and have a look at Aspect.io course, and that will give you enough to be dangerous. You can probably, after, I think the really important bit's about 2 hours, but after watching that course, you'll probably have enough to get started. The only thing that course doesn't do well, which I kind of added, is a lot of courses don't explain semantic attributes, and that's the thing about cardinality. Just make sure that you do create that really good data, because otherwise what you're going to be stuck with is sort of limited data, and over time you'd want to evolve that. So
yep, absolutely. The next one here is, adding context is important to dimensionality. Would you have some patterns or processes that encourage devs to append the relevant metadata to key transactions?
I think it's, so this is the way I would do it. So in my head, so I don't think there's actually an official answer. This is the way I would do it. And this is an exercise we'll do. Essentially, we want observability to be a culture in our company. So what we're going to do is basically a wargaming exercise where DevOps introduces some errors and devs have to, from first principles, deduce what's broken and vice versa. And what that should tell you is if we can't deduce from first principles what it is, then we should add more context that will help us to change that. So I think that's kind of the talk about observability culture, because there is nothing that there's no kind of, it's not one of those things like a code standard where you can say every line has to be 60, like, and it's also varies from business to business, because some of your data you may think is really, really useful, but when you actually look at the uniqueness of it across, it's actually not that useful. So like, let's just say the app version may be useful for a little while, or something like, you know, this is the logging library we use, and you may not change it for 6 months. Having that in the in your things may not change. So it's not, I don't think it's something you can evaluate until you start the journey of trying to troubleshoot. So we did the same. So our journey was, we started with tracing, and then what we found was tracing by itself wasn't enough. So then we added tracing to log correlation, and that gave us a bit more sort of, and that's how we kind of moved. We didn't try to do everything at once.
Cool, excellent. All right, so let me go to the next one. The next one here is, so cloud vendors have some observability tools, but I noticed snapshots and debuggers seem unloved. GCP deprecated Cloud Debugger, and Snapshot Debugger is open source software, but only supported by Google till August this year. What are your thoughts on that?
So of the two, remember we talked about the temple model, which was like a mental model. So exceptions and debugs, logs and trace, stack traces. I think they're not getting much love because people don't see them as kind of value add. I think exceptions are really useful, but it's not like an official signal. So I think what a lot of the cloud vendors are trying to do is kind of stick to the, remember I talked about the OGs, events are probably the one that I see next coming on. A lot of people realizing that this really is useful when you're looking at changes to kind of have a context to what's changed. If you look at the OpenTelemetry specification, you can actually stick your debug information, your stack traces as an attribute. So that could be an option there as well. But yeah, I think it's unfortunate, but I don't do enough development for that to be a pain point for me. So for me, it's kind of like, the way I look at this is, how can we expose that useful information, whatever signal it is. And the signal may not always be itself. So, you could have all your exceptions in Sentry and then you kind of link it together, as long as you can correlate your signals. I think that's important.
Yep. The next one is, how do you start to break down your blind spots in data gathering?
So yeah, once again, is you really have to commit to using the tools. You can't have, so, it's sort of like our evolution has been, when the devs ask us a question, we kind of go and open up the thing and we walk through them with it and then go, and then when we end up that the observability stack isn't giving us the answer, then that's the prompt to add that context. Because as I said, like, you probably should start with tracing and, logs and maybe some of those other things and metrics, and then kind of like think about the signals that make the value add. And it's not going to be the same. So I can't say that tracing will be the golden thing. Like, we have a problem at the moment where some of our tracing is really, really not that refined because we have a polling database. So our traces are just full of DB connection requests and things like that. Yeah. So we have to work on that. So every time we go to solve that particular problem, and that's where it's a journey. You can't just there's a lot of assumptions, but I think sort of like if you have the end goal in mind, you can kind of go, okay, we'll just filter those out. And there's plenty, and that's why OpenTelemetry is really good, because you can just filter out those noisy spans or those other things and then kind of go, did this, when I try to answer this question, did I get a clear thing? And why can I get it? Is it because it wasn't there? Or, and then you talk about reliability of the observability stack versus, I actually couldn't query it because I didn't have enough dimensionality. That's why you kind of think about those things, but don't get scared and try to think about it once. I think if you start with 1 or 2 data points that are not the standards, sort of like, what services it is running Kubernetes, you will build that, because the reason why you want to build that is because you will get the benefit of it. So become kind of like a cultural thing rather than a mandated thing.
Absolutely. That's it. We got through the stack of questions. Thanks so much for spending
No
that
problems.
extra time with us.
Thanks for the good questions. Awesome. No, that's right. That was really good questions.
Awesome sauce. Well, thank you again. Clap from on behalf of everyone who listened. Thank you very much again. And yeah, we'll absolutely continue to follow up and probably see some of your comments on the YouTube channel as well. And that way, if anyone has any more questions after you've kind of heard those answers, feel free to still post things. Just sort of maybe tag it and say that it's for Andrei. We can continue to collect those kinds of things and make sure that we can follow up with that afterwards as well. Yeah, we can deliver it back to the audience either at the end or in a write-up online.
Cool.
Awesome sauce. Thanks very much. All good. And that brings us to the next speaker here. We have Artem waiting in the wings. Are you there? Are you still with us?
Yeah, I'm with you guys.
There he is. Thank you very much for joining us tonight. Awesome. I'm sure there's a lot of really keen folks to hear about how they go about implementing single sign-on for single page applications. So without further ado, I'll let you get started.
Yeah, sure, no problem. First of all, wanted to say big thanks to Andrew. It was a fantastic presentation after all. And then, yeah, let me just start sharing my screen in here. Hopefully you can see it. All right. Can you?
Just certainly can. It's looking great.
Wonderful.
Thank you.
Wonderful. Okie dokes. Glad to see you all here, guys. And first of all, let me just introduce myself. I'm as said, lifelong IT professional, has always been doing IT stuff, and then currently I'm a front-end developer at a company called Mabel. What we're doing a platform for people with disabilities, and just essentially trying to connect, support providers with people in need, effectively trying to cause a positive impact on society. Anyway, I used to be a database engineer before, and I spent a few years working in that area. And yeah, aside from that, I'm also a dad of two, and kids always keep us busy with me and my wife. So yeah, life's wonderful. So anyway, if anyone wants to follow me on LinkedIn, there's a link. Highly appreciate it. Anyway, let's get right into it. What's the purpose of today's discussion about a single sign-on? First of all, I wanted to say that a few months back, it was an interesting topic to myself because there was a requirement on one of the projects that we did in the company to implement a single sign-on with the Google, especially for the people inside the company. Don't confuse it with a social sign-on, and I'm going to explain to you a bit later. So essentially, I understand that our audience could be so much different. Some people have heard about single sign-on and had a great deal of experience with it, and the others wouldn't. So we'll just reiterate what single sign-on really is. And next, we'll jump into overviewing the technology stack behind it, just to see what's working, what are the current standards, and then I'll then explain a bit about the industry best practices for the single sign-on and security aspects of it. And then hopefully you can just go ahead and try to explore it and do your own implementation, or maybe you just want to grab my my code from the GitHub and just try to play with yourself, really. So anyway, what's single sign-on really is? Basically, the idea is very simple. You as a user wanted to jump on a single authentication page, prompt your login credentials, and it'll take you to any of the applications you want to be authenticated within, right? Ultimately, that works in the opposite direction. If you want to, access SAP within your company, and it just takes you to the single sign-on page where you once again prompt credentials if those haven't been saved in the forms of some cookies or something else like local store or whatnot. And then after successful authentication, you jump back into your application, off you go. You work with it seamlessly, right? That's the whole purpose of it in a nutshell, just trying to keep it really simple. Let's reiterate what we would have done without the single sign-on in the company. Pretty much all of us start building our application, implementing a simple signing with probably an email or a username and password. Maybe just remember the password taken there as well, and then just a login button, right? No, nothing really fancy. But what we could do with a sign-on, especially like talking about my experience really, is that we'll just add another button in here that'll take us to the single sign-on experience. Just once again, for the sake of the presentation, it's gonna be a Google sign-on page, and after I prompt, say, an email or something like this in there and just authenticate fully, it's gonna take me back to the application and get me signed in. So now, the important topic to talk about is that what is actually working, like how the sign-on is actually done behind the Google, for instance. It might not be a surprise for many of you who are familiar with the single sign-ons that most of the corporate type of applications are actually working with a protocol called SAML. And it's, as you can see, it's basically a set of XML parameters that are sent to the authentication server and back from it in form of request and response. Well, SAML stands for Security Assertion Markup Language. Basically, as I said, it's true enterprise level, quite a complicated markup. Essentially, not that easy to work with if you come from the front-end world like I am. But that's unfortunately in some of the identity providers like Google, it's the only way of doing this, and coming back to the topic of how we can simplify it and what would we expect from the front-end perspective is we wanted to implement something simpler to us that is Auth2 protocol and probably an OpenID on top of it. Just to once again simplify it a little bit, what's the Auth2? It's just a authorization flow that basically a user request, the application that you're interacting with might just request something from you, like a resource owner, saying like, I want to access your contacts from Google, and then you say, yeah, okay, I just read what you want to do. I grant you the access, and then application requests, authorization from the server, gets the token back, and passes the token to whatever resources it's trying to access, right? So the OpenID, however, on the top of it is really what's authenticating the user, just really trying to establish who that really is, what's the scope of of the grant request, and what are the other bits and pieces like redirect URL state and whatnot. We'll just go into the details a little bit later, probably in a demo or something. So, and it'll bring us to, a talk about what's the social logging, and, as I said, a variant of the single sign-on. You've probably all seen, like I presented the, so let's go back to this slide. Sometimes on the website, you would see under the login button various logins with Facebook, Google, LinkedIn, and some other social logins. The key difference here is that basically user can authenticate on your pages using all these identity providers, and this will ultimately create all the sets of users within your application too. Which basically could be good for user in terms of user does not have to create identity each time he logs in. But if you authenticate a couple of times within a different authentication mechanisms, then there is really a difficulty on how you can link all these accounts together, or can you at all? And this is one of the drawbacks from it. But if you are a company, as in my example, trying to use Google as an identity provider, then you really want to act as your identity provider, really, and providing the authentication to the users within the company. It's going to be a little bit of a different story, right? And I know that out there, probably familiar with Okta and Auth0 companies that basically the beauty of it, they provide the whole set of libraries that can achieve authentication with the most secure way possible, but at the same time they offer this linking mechanism between the complicated SAML and identity providers like all of like Google's and whatnot. To sort of bundle it all together, but one of the drawbacks could be really is that basically those services typically are paid, and specifically on a smaller projects or a little bit of R&Ds, you may not want to use it, and you want to explore the methods of authenticating with a single sign-on yourself, and that's exactly the case I wanted to present to you. Let's pretend that we are building a new feature and we're just adding the new signing button, right? Let's imagine what the authentication flow would be, because currently we know if we use just standard front-end, back-end, chain, then on the back-end we would probably have an authentication mechanism which verifies the username and the hash of the password against the database. And if that's valid, it's probably gonna give a front end a bearer token that can be used to access all the other resources it's really needed. But what if we think about the SSO and additional identity provider? How would the flow look like? And simplistically saying that that's your flow. So basically, from the web app as a user, we initiate the single sign-on session. And because previously I said the SAML is quite a bit complicated, and there's a few security aspects to it, the initial signing handshake cannot originate in the front end, or at least it's not the best practice, because SAML requires that you sign your request and verify the responses with the certificate that you basically your identity provider would give you. So you would naturally want to keep it secret. And as you know, nothing on the front end is really a secret. This is why we would just pretty much create the request on the backend side. We would, in my demo, it will be Node.js. So basically, the backend really serves a purpose of redirecting to the identity provider with the created SAML request as an HTTP post, and then it's taking you to identity provider, for instance, a Google, and then user is presented with the normal experience, which we call maybe an account picker. And once the user successfully authenticates there, then identity provider basically redirects back to our backend with the token, and where backend can verify the authenticity of that token with the help of certificate once again. And once the backend is happy that the user is valid, we can verify additional criteria. For instance, if the user is part of the certain roles, if he is enabled in our system and whatnot, and then if all the checks are passed, we just log the that user in by redirecting back to the front end with the bearer token. Obviously, you may ask me, what are the security aspects of it, redirecting to the front end with the bearer token? Because in case of the single page applications, it's very difficult to keep that bearer token secret. So naturally, you'd be transmitting it as a URL params, and even though we live in the age of HTTPS and TLS traffic and everything, it's still prone to some attacks where the TLS is basically downgraded, and then the man in the middle can really intercept the bearer token, and you don't really want this to happen. So what we can do, we can then take an advantage of Auth2 idea and basically implement a few more steps. So initially, it'll look a little bit different, a little bit scarier, but what we can do on the front end, when we initiate the session, we'll just create a random phrase, which will be our code verifier, and then we'll hash it with the SHA-256 and call it a challenge code. And we'll also generate something called state. I'll explain what that is in a second. But that's just another random phrase. And with that being said, we just initiate the redirect to the backend, sending the state and the challenge code. And then same thing happens, backend basically posts and cooked up SAML request to identity provider, user logs in through normal sign-in experience. And then once the identity provider is happy that the login password correct and everything, just redirects back to the backend with a SAML token. Where backend also runs the verification against the response sent from identity provider, and if backend is happy, it'll generate something called auth code, and the intention for it really is to use it to exchange for a bearer token. So this auth code is then sent back to the front end application, where front end has to go one step further and then obtain, like, it'll basically exchange the auth code for the token, providing the code verifier to make sure that the requests have not been compromised. And well, obviously the front end then check the state that's coming back from the backend with the auth code. And if the state is the same as what we started the authentication from the step one, then front end will try to exchange the auth code for the token, and everything is happy. Then we get the bearer token back. We save it somewhere in the local store, or if we use state management, we'll store it there, and happy days. Now I can show you the demo of what I did. So basically, it's a pretty much simple Angular application with above mentioned authentication mechanism. The idea really is I press the sign in and it uses my Google account and gets me signed in, right? That's exactly what we want. So quick overview of what's happening behind the scenes. I've got a simple Node.js server, and I'll go through a few bits and pieces here. We use just a handful of endpoints. The login with the get is what really starts to redirect to the identity provider, and then basically all it has to do is just create the SAML request and send it through password to the identity provider. And then once the identity provider comes back with a response, it accesses the post endpoint with login to, and from there we can verify who, what's the username that coming back from in the request, and a few additional bits and pieces, and then we'll just create generate an arbitrary, like in my case, an arbitrary bearer token, just for demonstration purposes. So, and then basically this is the route that basically will serve the purpose for exchanging the token, right? I'm not so sure what's the best way of sharing this code, because those are my repos that are in public access. I think we might just share them after the talk, so people can browse through them and shoot some questions if there are some. But anyway, I'll just show you the front end bit of it real quick. So basically, this is the page that you saw here, and just the one button. I have a click event here, and then basically I built just a little feature to allow me to sign in with redirect or with just pop-up window, just for demonstration purposes. If I just log in with redirect, you'd expect it to take me. It was super quick, but it took me to the Google sign-on anyway. Yeah, so what's happening behind the scenes? Just trying to elaborate a little bit on this flow diagram. Just go real quick, just being aware of time. We'll go with redirect and explain what happens. So we're creating the state. How we're doing it, we just create random string out of those characters, and we just basically store it in the local store. Show you in here, just SAML state. Wonderful. And also when we do login with redirect, we create the challenge code is also like created using a random string. It then gets hashed in here. And well, basically the original string is stored in local store, so we can send it back to the backend at the very last stages. But anyway, the actual hashed value we return and send back in the redirect itself. So at this stage, basically, we handing over to the backend and to identity provider, and effectively in here we just leave Angular application. Then when it comes back to us as a meaning of redirect, so we just handle redirect callback here, and we expect that in the URL params we would find the state that's been previously generated, and we find the auth code being sent to us from the backend. And we, if state is present and auth code is present, we just try to exchange those for token just by extracting those from the local store, because obviously Angular application at this stage has been reloaded. We just need to fetch them back. And
sorry to interrupt. Can you increase the font size of your editor?
Oh yeah, absolutely.
To see it on YouTube.
I thought it might be enough, but it's not really. I'll just make it super big for you, so it's easier to read.
Thank you.
Yeah, I'm just really trying to explain the flow real quick in here. So yeah, basically just retrieving those states and code verifier, and then making sure that everything is present, and saved state that we just have written is the same that's coming us to the backend. So we know there is no the request or sort of redirect hasn't been compromised. We just try to exchange it for the token. And if we encounter any errors, we just throw a new error which we handle in the component level, saying that sorry, we could not really proceed with authentication. Yeah, that's just it. And if everything is successful, happy days, we pass GWT token. And on my sort of very simplistic example, I just call it do login, and then pass it to authentication service, right? That's pretty much how it works in a couple of words, but a word of caution to anyone trying to do the same. The reason why I mentioned that people normally lean towards implementing stuff through Okta and Auth0, because, well, obviously each and every day there might be new vulnerabilities in different approaches and different functions that generates hashes and go through an entire flow authentication. You're better off sticking to high-profile vendors for implementing this. But if you're doing it as your pet project, or you want, like me, dive deep into how the SSO actually works behind the scenes, that's the way to go, and that's what you can pretty much explore and do it yourself. I'm sure there's going to be plenty of questions, and this is why I've actually given plenty of time for you to ask them if you have any. I'm sure you will.
Thanks very much, mate. I'll just put my video back on so people can actually see me. Thanks very much. And yeah, excellent to be able to, jump in and make sure that we get some extra questions from folks as well. We've had everyone kind of mesmerized and trying to follow along with the code. I think that's been pretty good. We've got 3 questions here that I've got so far. If you've I know you're going to be on a bit of a delay, everyone at home, but if you've got some questions that you want to jump in with, please do. Now is your cue. So one in here is, I've used Node Passport in the past to help make this easier. Is this still the best and brightest that's out there?
Well, I think, once again, for the purpose of, doing a bit of a R&D or trying to implement in your pet project, or like really, doing something smaller scale, I think, yes, Passport is a good way to do it even these days. because I played with it myself, and I found that code is not really complicated, and it's easily achieving what I wanted to do.
Yeah, that makes sense. Absolutely. We've got another one here, which is some providers like the Google account from your example will have an OpenID Connect endpoint that's certified. If this is the case, should we still bother with SAML? I guess they're kind of interested to know what the pros and cons might be.
Yeah, that's right. I think I did not really explain too much about why in this particular example, the Google hasn't forced me to use SAML. Is once again, in this particular case, I'm using Google as an identity provider, not as your just generic social login and whatnot. So it's basically what do we call it? Google Workspace authentication, and the only mechanism, and I can actually show you real quick on my screen once I have it open. Just share one more time. So basically, the only in the Google Workspace, the only allowable way for you to, oh my God, this once again prompts me for password. Sorry for that. If I get it correctly. So the only mechanism that it allows you to create an app with, like it's just a custom SAML app, or you might create an additional like Android web application or something like this. Unfortunately, Google Workspace does not really provide you with a handy mechanism of using OpenID and auth to the top of it. So that's the driver. It's really kind of an identity provider to use in your, I guess, the corporate landscape. Is basically Google using most like organizations, like not most, but many organizations to as your like Okta or Auth0 to provide a single sign-on for pretty much all the applications within the org, whether it's Slack or SAP or anything like really, or up to the in-house built applications like I was showcasing. And yeah, once again, Google Workspace only supports SAML. Sorry for that. Good old days.
Yeah, I guess it's a pretty big target for them, so that they can make sure that they maintain integrations. Everyone's going to try and support SAML anyway, so that'd be their biggest market to try and target first.
Yeah,
but no, that's completely fair enough. So yeah, I think we had the same question, different phrasing. SAML seems to have been replaced in some ways by OpenID and OAuth. Do you have any opinions on the differences?
Well, the key difference, as I mentioned, basically, is that SAML really does not allow you to initiate the signing and complete the signing on the front end because of the security aspect. So that obviously, to my liking, I would lean more towards the OpenID, because it's quite handy, a lot easier to implement for us, like front-enders. All we need just a bit of a configuration from the ops, and we pretty much would be ready to go. But no, unfortunately, we still live in the days where there is a mix and match of what you can do, what you have available at your disposal. And yeah, but ultimately, yeah, if I answer the question correctly, the OpenID is something I would like to see on the project, like in the future.
Yeah, absolutely. And I guess if you're using something like Auth0 and you're doing it for like internal login, like you'd be connecting like your Auth0 like tenant to your LDAP or something for all your user identities, and then you'd be able to kind of get it to be the OpenID provider, and then you can sort of integrate with that. You don't have to kind of go with the social logins from other folks as well, because you're kind of more in the corporate space or internal workspaces. So you've got options depending on what your kind of need is, I guess. Yeah. So yeah, the next question we have here is if you've got multiple services behind a single login, can we look at JWT? I'm assuming that's also a should we, or is that relevant? Do we use the same session or the same token across those? How do we share that authentication?
Yeah, absolutely, and that's what I mentioned in my talk, but I didn't call it JWT. I call it just bearer token. I was sort of assuming that behind the scenes we would use something similar, or JWT in the essence. But ultimately, you know, with JWT, once you got issued that, you can reuse it for a number of applications, providing that the secret is shared across them. And say you have basically micro front-end application that talks to the various bits and pieces. And once you acquire that JWT or bearer token from my presentation, for the sake of it, then you're pretty much free to go and access any resources you want. Yeah, and this is relevant. And this is my key point, that the whole presentation was just about adding the Google single sign-on as an additional identity provider, retaining the old infrastructure that's been put in place, right?
Absolutely. It gives you extra options.
Sure.
And we've got one more. So how did you weigh up the various SSO options? And had you used SSO before? If someone is new to SSO, where is a good place to start if your team needs to implement it? So it's kind of a multi-part one. I guess the first question there is, what kind of SSO options did you weigh up, and had you used it before?
Well, obviously, so I think the rule of thumb, you go out to the internet, you just type in SSO single sign-on in the Google search, and I bet 100% that basically you would see big names straight off the bat, Okta, Auth0, and so on and so forth. So basically, I would really I wouldn't mind using them at all. It's just one of the project restrictions where that we do not want to employ an additional service provider, identity provider, and additional configuration and whatnot, because at the time we already had Google set up for pretty much across the board. And then that was the catch in it. My personal experience with SSO, I'll tell you, I've been always a user of an SSO, but not really implementing it from the ground up. It was also a learning curve for me, and this is why I thought I might just share my thoughts and my experience with you guys.
Yeah, great.
Yeah, that's the case.
That's awesome. And then I guess part B was then, if one is new to SSO, where's a good place to start and to learn if your team needs to implement it? I guess outside of just the web searches, was there any resources that you found were like invaluable?
Yeah, absolutely. I think, what I can give big credit to Auth0 is that they have an absolutely fantastic documentation for SSO. And plus, once again, I explained to you about the whole mechanism of acquiring the token that actually called Pixie. And the Pixie mechanism is very well explained in the, I think, Auth2 specification RFC. I can't remember the name of the RFCs, but I was referring this document. I was like reading it quite thoroughly, and it explains all the bits and pieces you want to know about it. Specifically about why you shouldn't be transferring your bearer token through the URL params. It's really a bad idea. But give or take, for SBAs, sometimes it might just be one of the feasible options. It's less secure, but but still doable.
Yeah, absolutely. And then if you got JWTs, you can always make sure that they're validated cryptographically against your backend every time before you go and actually give anyone anything, right? So
absolutely.
So that's kind of a nice end-to-end checking mechanism. So that's great. I haven't seen anyone jump in with any last second ones in there as well. So we got a couple of extra ones that came in while we started answering the questions. So that was great. Thank you for everyone for getting the signal and jumping in on time. So that's fantastic. Thank you so much for giving us that presentation and running us through a little bit of how we can kind of get started as well, and some of the pitfalls. I really appreciate it. Also, again, big hand of applause from all of our folks that are out there, clearly liked by everyone on there, and really appreciate your time and coming out and chatting with us tonight.
Awesome. Thank you.
Thank you. If you've got any more questions, you can always go through and send them to us. We'll make sure that in some way, shape or form, we can go through and republish some of those answers and also share the assets. So we always try and share some of those assets through the GitHub links of the specific talks as well. So our presenters will try and link them to those pages, those issues as well. before we close them, we tag them as having resources shared as well. So you can find all of the ones that we've tagged and folks have shared their resources on before as well. So yeah, that brings us to the close of tonight, actually, everyone. I will put one of my last screens up here so you can see a couple of our extra links and understand where you can keep in touch with us as we keep going forward. If you're a first-time BrisJS watcher, thank you for joining us. You know, sometime this year, hopefully we can get back in person. We'll get back into one of the venues and get our sponsor crew back on so that we can host you with some pizzas and the like. And but for now, we're always going to make sure that we have the regular live streams and make sure that you can still keep getting that great content and keep getting the word out. Keep using this as a platform so that you know you can stand on that and make sure that everyone can hear and benefit from the knowledge that you want to share with us all. But yeah, thanks very much again. And you know, these links here, do check us out on Twitter and brisjs.org if you wanted to have a look at any of those links. You can reach out with me to me. I'm Kevin Van Der Beeken, if you didn't know, and you can reach me at my Twitter at KevDesign, and there's also kevinv@brisjs.org. That'll go straight to my email. But yeah, if you've got any feedback or anything you'd like to share with us at the end of this evening, you can use the Slido as well. I put that into, and I'll click the button over here. I'll put that into feedback mode. You know, how do you rate that? And you know, do you have any suggestions that we can employ to help make things better for you? Yeah, I hope you'll check us out next month. We'll try and make sure that we've got all the talks lined up ahead of time, so we don't have to jump ahead an extra week. Thanks for bearing with us for that initial misstep. And well, if you've got a talk you'd love to give, please be in touch. That is the absolute lifeblood of BrisJS. We absolutely need your content, need your talks. So we're very keen to support you to make sure it happens. And that's enough from me. Thanks, everyone, and we'll see you next time.